All right, so today we're going to talk about factor analysis, and we're going to go an overview of exploratory and confirmatory, but we're really going to get into exploratory factor analysis. So I've got some examples, some links to maybe some silly examples. So the first one is a 2007 study. They looked at personality in cats, and they had people rate their cats. So they had 196 cats, and they did a 5-point Likert scale. And there were 12 items: timid, friendly, curious, sociable, obedient, etc. And what they found was it was a 4-factor model, and they had one factor that was active, clever, curious, and sociable, another factor, emotional, friendly, protective, third factor, aggressive, bad-tempered, and the fourth one was just timid. So in this example, they found a 4-factor model of cats and the cat's personality. In humans, they found a 5-factor, the big 5 it's often called, of personality. In the second link, they talk about a 1-factor model of personality. They've taken all the 5 factors and they've looked at how 1 factor of personality, and it's more of a, it's not a great study, but just is there 1 factor? And I think one of the better examples that we use in psychology of factor analysis is looking at the WAIS. And I've got here, actually let me go to the next slide and I'll come back to this one. This is what we look at when we look at the WAIS in our cognitive assessment. So we've got our different factors: verbal comprehension, perceptual reasoning, working memory, processing speed, and then we have our subtest and how these subtests load on each of these. So it's kind of interesting. So what we're looking at in factor analysis is a factor, and factors are in this example here are circles, and what loads on each factor. So which items or which subtest load on each factor. So, and we can see here, and we'll get into this in more detail, this is the factor loading. The higher the number, the more the factor loading. So verbal comprehension, vocabulary is the most important item loading on verbal comprehension. Perceptual reasoning, block design, and matrix reasoning are the highest loading, and visual puzzles is a bit lower, and that's one of the reasons visual puzzles is an optional test. Working memory, arithmetic and digit span, and then processing speed, both coding and symbol search seem pretty important. So you can kind of see where they might have gotten the idea for the WASI, the abbreviated intelligence test. They said, let's look at which items load on the highest. So in the WASI, I believe they give vocabulary and matrix reasoning, and so a 2-item WASI, I believe those are the two. So they're looking at what items load the most. So with the WAIS, we're usually talking about these subtests, but we're also talking about a full-scale IQ. Here it's labeled G, and G is going back to Catel's original, or even before Cattell, Spearman's G, and this was his general factor of intelligence, and he thought G was a definitive idea of how everybody has a certain amount of intelligence. So he didn't break it down. He said there's just a G, and so this is labeled G instead of full-scale IQ. But we can see how each of these. Now we've got a little bit of a oddity here. This one looks like it's a 1. I believe that's set by the software. In this paper, usually one of these is set to 1 and then the rest go from there. But I'd have to look at that paper a little bit more. The previous slide gets at a different model of the WAIS, and this was done in people who are older. And this is something that's pretty important to intelligence. Does the factor structure stay the same over time? And you can imagine a 2-year-old or a 3-year-old, we're looking at how many words they say. That factor structure, that's probably one of the most the best indicators of intelligence, versus somebody who's 70, that something is maybe different. So this is what they found for people who are 70. There's a few other factors. So and they kind of load even slightly differently. So we've got a C probably stands for gosh, I don't even remember what these GC and GV, but you kind of see some differences in how these things load together. Matrix reasoning and arithmetic load together for people who are older. And maybe we can think of this, in that sort of this fluid. And this is crystallized. Crystallized is to see. This is fluid intelligence. This is that having to figure things out. And for our people who are 70, this is how these items load. They broke down digit span into the different components, and this is a short-term memory, and then a speed. These kind of go together. So you can kind of see a slight different factor structure for people who are older. And so we're going to get into more detail what this all means as we go through this. We've got a lot of definitions in this lecture, and I apologize for that. There are whole books written, quite a few books written on factor analysis, as it's just a big process. So we're talking about exploratory, and there are these different steps. So the first step is we have to extract the factors, and we're going to have to make some decisions in how we extract the factors, how many factors do we extract, and that's really the art of factor analysis. Then we're going to rotate it, and what that is, it's just a mathematical thing that we do, and that helps us interpret the factors better. And there are different types of rotations, so we have to make decisions on the rotation as well. So this is where, again, there's a lot of terminology in factor analysis. So every type of rotation has a different term to it. And then interpretation, we have to interpret our factors, and that, again, is where there's some art in this type of analysis. So exploratory factor analysis is basically we're looking at a bunch of items and we want to see how they all relate to each other. So with the cat personality, we had 12 items of personality, and instead of just asking, on 12 items, which is a lot to talk about, how do these lump together? How do these different items lump together? And what we want to do is come up with factors where items lump together. And we can think of a depression measure having let's say 7 items, and this is my made up little depression measure. So we've got, feeling worthless, guilty thoughts, crying, feeling fatigued, hopeful, satisfied with life, and feeling energized. So if we came up with one factor structure of depression, and here's my one factor structure, on the positive end, we have things such as, on the negative end, I've got this reverse. We've got these sort of negative aspects of depression. This is feeling depressed. And then on the other end, we have the opposite of being depressed, feeling energized, feeling hopeful. So a one factor structure, we've got the things that are really associated with depression and the opposite things of depression. So that could be one way we describe all of these 7 items, just one factor. Maybe that's not the best way. Maybe we could do it this way as well. So on this axis, we've got feeling worthless, guilty thoughts, and feeling hopeful, satisfied with life. And this is maybe the more cognitive components of depression. So maybe the things that are negative cognitive components, more positive cognitive components. On the other axis, we've got more physiological components. So we've got the negative components, and then the more positive components of physiological, feeling energized, and then the opposite end, feeling fatigued. So this might be a better structure for this fake depression measure. So we have to kind of figure this out. We have to figure out how many factors there are for these items. So when we do the factor analysis, the exploratory factor analysis, again, this is somewhat like that WAIS drawing. We break it down into different components. And so what's in the square are things that we measure. So let's say this X1 is feeling fatigued. It's something we ask people, how fatigued you are, and this is what we measure. We also, in here, this is a kind of grayed out. The X2 is guilt, and so another thing that we've measured. We've got a common factor, and so this is what's called a common factor. It's depression. It's a common factor. It's related to all other variables. So this depression is what we'll say is indicated by feeling fatigued, and indicated by guilt. So sometimes we say loads, fatigue and guilt load on this, or depression is indicated by these variables. So that's that factor analysis part, or the exploratory factor. We're trying to find these common factors that relate to everything. We also have unique variants or unique parts that are not related to depression. So this unique part down here, and sometimes we call this error, this is the unique part of feeling fatigue that's not part of depression. So if somebody, I mean, you may be feeling fatigued right now and you may not be depressed. It might be something completely unrelated to depression. Could be that the person just stayed up late last night, or is worn out from generalized anxiety disorder, or something else. This unique factor is not related to depression. So this is what's left over. It's often, I'll call it error. Error is maybe not the most correct term for it, but it's what's left over. And then the same thing on this one, we have what's left over. This is unique to feeling guilt, and this is what's left over, not part of depression. So here's what's here's in text form, basically what I just said. We'll also talk about exploratory versus confirmatory factor analysis. And this week we're talking about exploratory factor analysis. Next week we'll talk about, or after the break, we'll talk about confirmatory factor analysis. So exploratory is when we're starting from scratch. We've got this measure. We don't know what factors make up this measure. We're basically going to say that each factor is indicated by each and every variable. So in this situation here, factor 1 is related to all of the variables, factor 2 is related to all of the variables. And what we want to see is how much each variable loads on each factor. So let me get rid of the mess here. So for example, x2, let's say x2 is block vocabulary, and we have crystallized intelligence, and then we have fluid intelligence. We want to see that vocabulary is a crystallized skill. It's something that once you've learned the definition of a word, you have it basically forever. So it loads on crystallized at 0.80, according to the factor analysis that we had earlier, and it loads on fluid at a much smaller number, so let's say 0.10. So vocabulary is not really a fluid skill, it's a crystallized. So we want to look at the factor loadings to see how the items load on which factor. So this is exploratory. We're basically doing this to say, yep, vocabulary loads on crystallized but not fluid. Block design, or matrix reasoning loads on fluid and not crystallized. So we're exploring the data. Confirmatory is once we already know a factor structure, we can then confirm that this factor structure exists. So for example, let's say we've looked at the WAIS, and then we're looking at people who are 70 to 90 in that earlier example. We want to confirm, does this same structure exist for a different population or a different group of people? So this is more confirmatory. We have a theoretical idea of what the structure is. So we're not letting F1 load on X2 or F1 load on X3. We're saying it only loads on X1. So because of theory or because somebody else has already found this. So this week, again, we're going to focus on exploratory. We're going to go through the steps of exploratory. It's very different than the steps of confirmatory. All right, so with exploratory factor analysis, again, there's a lot of steps. So I'm going to take you through these steps. So the first step, again, is extraction. This is how we extract factors from those variables. So we're trying to find out what are the latent constructs underlying all of these variables. So we'll have to pick a method. There are a lot of names for the different methods that we have. I'm going to kind of break it down to the ones that you should be using. Then we have to decide how many variables we're going to extract. Because, for example, on the WAIS, if there are 10 subtests, if you give this 10 subtests version, you could create 10 different factors to extract, but we're going to decide how many variables we're going to extract. So there are some ways that we'll do this. We'll talk about these different ways as we go through. And then the last thing that we'll do is really rotate the factor structure to make it more interpretable. And then, so again, I apologize for all these terms. I'm going to go through these in great detail as we go through this. So the first step is picking a method. When you're in SPSS, the default method is principal components analysis. Principal components analysis, I've got it in red. It's not the way to do things. And I'll see even the cat factor structure was a principal components analysis. There are some reasons not to do this, and I would suggest strongly you never use principal components analysis. And part of the reason is that you're assuming that the measurement has no error. And whenever we measure something, there's error involved. And I'll show you in the next slide. Actually, I'll just show you real quick. So principal components analysis right here, we're basically saying that this item predicts this component. It's almost like a regression type of analysis. And there's no error left over. There's no unique variance associated with this. And this is why I say that we shouldn't do component analysis, because there's really going to be error associated with each of these, or unique variance associated with each of these. So with component analysis, it's not there. So that's why I say don't do component analysis. Don't let friends use principal components analysis. Even though it's the default in SPSS, you have to change that default. And I'll show you how to do that in SPSS. The things that we're probably going to use are maximum likelihood. And when we start using M+, we'll use more of maximum likelihood or principal axis factoring. And this is what I would suggest you use in SPSS. So principal factor analysis, axis factor analysis in SPSS. There's many others. You'll see the list. And you'll need those once in a while. So there's a weighted least squares mean value type 1. And if you have a Likert scale, you'd use that. I'll look things up if I have a strange sort of scaling. Actually, I wouldn't use that if you have a Likert scale. If you have something that's dichotomous, I would. That's when I would use that. But there are different types that you can use. When you use different types, you risk the chance that you could have different solutions or different answers. So you hope that you get the same answer with all of these. So with these two, quite often the same solution comes out, but not always. So that's another issue with factor analysis, and some people have called it voodoo. I don't know what that means exactly, but that you might get a different structure depending on some of the choices you make with this. But again, I would choose principal axis in SPSS or maximum likelihood for the extraction type. And again, when we do maximum likelihood or principal axis, we get this nice factor structure. Principal components, we don't get this. So we want to have leftover unique variance. These are not measured perfectly, and they're not measuring just this component. So there's unique parts left over. So that's why, again, we're going to use maximum likelihood or principal axis, is we want this factor structure. All right. This is just text, hopefully explaining what I just said. The other thing we'll do is we'll rotate the factor structure to have it make sense. And I'm going to talk about rotation and describe what that is actually in a few minutes, but there are two types of rotation. There's oblique rotation and orthogonal rotation. And the big difference, if you look at these two figures, there's only one thing different, and it's this right here, and this one doesn't have it. And what this is, it's a correlation. When you see this double-headed arrow, it's a correlation. So this method, oblique rotation, allows the factors to correlate with each other. Orthogonal rotation, the factors don't correlate with each other. So if we go back to the WAIS and we think of something like verbal comprehension and perceptual reasoning, there's probably some relationship between those. There's probably a correlation between those. So we'd probably want to use oblique rotation. And in actuality, we probably always have a situation where things are related to each other and correlated. So we probably always want to use oblique. There's going to be reasons we use orthogonal, and I'm going to tell you the main reason is it's much easier to interpret. And the example I'm going to give later is orthogonal just because it's easier to interpret. So we probably think things are always correlated, but we'll do a lot of orthogonal, saying the factors are not related because it's easier for us to interpret. So here are the types of rotation. Again, I've already mentioned that the orthogonal factors don't correlate. Oblique factors do correlate. In general, orthogonals are the max, varimax, quartermax, and equimax. However, oblique has a max and there, a promax, so it doesn't hold completely. What I'll do usually is when I do it in SPSS, I will just use varimax as my orthogonal rotation and obliminum as my oblique. To keep it simpler, but there are different reasons to use each of these. And I think I took the slide out describing what each of these do, but you can look it up in the chapter. But again, the important thing for you to remember right now is the factors correlate or don't correlate with each other. So, and when we go through the example, I'll go through the different types. All right. So here's what rotation actually is, and this makes our factor structure easier to interpret. So when we're doing the math behind this, we extract one factor at a time. So let's say with this example here, these are my 7 items for depression. The first factor that I extract is this one factor, positive, negative parts of depression. So it kind of has to fit here in order to get that first factor. I take a second factor, and it's whatever is left over of the variance, and it sits right here. So when I look at this, these two items aren't really close to either of these lines. So what I'm going to do, and this is conceptually what I'm going to do, mathematically I'm taking a matrix and doing something much different. But what I'm basically doing conceptually is rotating, this is a strange animation, but it works, I guess, rotating these axes to line up with items better. And so I'll say that again. I'm going to rotate those axes to line up with items better, and that helps us interpret things. So now on this is one factor, I have the cognitive components of depression. And on this other factor, I have physiological components of depression, and the items line up with a positive or negative direction on each of these factors. So that, again, the rotation makes things easier to interpret. And this is a orthogonal rotation. Because I have 90 degrees here, nothing is correlated with anything else. If I have an oblique rotation, I'm allowing those factors to correlate with each other. All right, and I did leave this actually in, so I've got my different types of rotation. This you'll see in SPSS when we go through the example. The Varimax is the one that I often pick, and then for oblique, where I allow things to correlate, I usually do obliminum, just because I like to say that word. So this is the oblique rotation I usually use. All right, when we do exploratory factor analysis, we need a lot of participants. So this is not something that we have small samples for. So I would say 100 or more people. And I have found this number that if you, and I would actually say more is even better, but at least 10 times as many participants as you have variables. So if you have a 10-item measure, you need at least 100 people for those 10 items. If you have a 20-item measure, you need at least 200 people. And I've seen this number go from 5 to 20, but I'm kind of saying 10 here, that you need, basically you just need as many people as you can. right, so here's an example. This is the Anxiety Sensitivity Index, or the ASI. And the Anxiety Sensitivity Index gets at how much people fear bodily sensations. This has been one of a measure that's been used for factor analysis multiple times. So when they originally created this measure, they thought it was one factor, just anxiety sensitivity, this being sensitive to anxiety. And when they started to look at it, they found that there might be some more factors to it. So here are the items. Let me find some important ones. This one's a pretty good one. It scares me when my heart beats rapidly. So this is that fear of physical sensation. It scares me when I can't keep my mind on the task. So something about my thinking almost. And it scares me. Other people notice when I feel shaky. So this one might be a social component, and I'm kind of giving you some ideas of what the factor structure might be. But just here's the questionnaire. The first thing we'll do, and I'll show you this in SPSS and live demonstration so we can go through this and ask questions. What we'll do is we'll put the variables over here. We'll click on rotation, and this gives us our extraction method. I'm sorry, this gives us a rotation type. We're going to choose Varimax and Orthogonal for our rotation, and then for our extraction, we're going to use principal factor analysis. So we'll have to click on these boxes. Often we can keep the defaults in SPSS, but in this situation with factor analysis, we can't, and that's why we have to go over all of these different terms as we do this. All right, with our output, we get descriptive statistics. This is always important to look at where all the items lie and what type of sample you have. In this sample here, I have college students. I believe this one came from college students and not the clinic. But actually now looking at this number, that's a pretty high number for college students, but I think this is still my college student study. And so we've got 2,000 people in this, so a large number. We need a large number to do factor analysis, and then we can look at our standard deviations. We probably should look at skewness and kurtosis as well, and I'll just assume that I've done that before this step. So when we do our factor analysis, we've got to pick out our extraction method, and we did principal axis factoring. But the next step is how many factors do we pick? And we could have, in this example here, we've got 16 items. So we could have 16 different factors. And that really isn't that helpful. If we have a 16-factor questionnaire, try interpreting a 16-item questionnaire. There's the 16PF, which is a personality measure, but there are hundreds of items on that. So bringing that down to 16 personality factors makes it easier to interpret. But for ASI, we probably don't need 16 factors. So we have to figure out what's the least number of factors we can extract and explain a lot of the variance. So we want to be able to, with our factors, explain most everything. And what basically I'm talking about there is we have very little unique variance left over. That error on the bottom that isn't explained by the factors, we want to reduce that as much as possible. So one of the things that we can do is look at an eigenvalue. So an eigenvalue is, well, conceptually what you can think about an eigenvalue is how many variables does this explain? And so we're going to get an eigenvalue for each factor, and we want to see how much each factor explains. So if we've got eigenvalue of 3, we can think of that factor explains 3 different variables. And I'll show you this in greater detail. If it explains, an eigenvalue explains less than 1, we probably don't want to keep that factor because it explains less than 1 variable. It's not really adding a lot to our knowledge because it's explaining less than one variable. So let me show you. Here's a table with eigenvalues. This is one of the first things you'll get out in your SPSS output. The first factor explains, this is the eigenvalue, it's 6.3. So it basically explains 6.3 different variables. So that explains a lot of variables. That's a really good factor, and we're gaining a lot out of that. We're getting a lot of bang for our buck with that factor. It explains 40% of the variance, so we're explaining a great deal. So you can see why the ASI was originally thought to be a one-factor measure, because we have this one big factor that's associated with it. But if we go down a little bit further, if we take a second factor, we get another 1.4 variables worth of data. And again, this column here is the eigenvalue. I'll try to write this, but this is our eigenvalue. And this second factor explains another almost 9% of the variance. So it is explaining a lot of the variance, so that's a good thing. A third variable still explains more than one factor, and so it's useful, and it explains 7% of the variance. So if we were to take a factor structure with 3 factors, so based on the eigenvalue, this is one way we can decide. We take as many factors as they have eigenvalues over 1. So this fourth factor eigenvalue is below 1, so this is where our cutoff is. We're going to take 3 factors. In this example here, we'd explain 55% of the variance. So this is one way to do this. It's kind of a nice little cutoff. That's one way we can figure out how many factors to extract. Another way we can determine how many factors to extract is to look at the scree plot. So a scree plot is a plot of the eigenvalues, and scree is what's the small little rocks at the bottom of a mountain or a cliff, and supposedly when the little rocks start where the scree starts is where you should cut off your factor structure. So for our example here, again, this is at a slightly different table. I'm not sure, I have a different scree plot here. You can kind of see if the rocks are falling off the mountain, they're all going to kind of land right in this area down here. So we would probably take, it looks like either 3 factors or 4 factors based on the scree plot. If this frustrates you looking at a scree plot, there are a lot of people that get frustrated with this idea because there's no clear indication. Maybe we should take 2 factors, maybe we should take 3, or maybe we should take 4, because the scree is going to be in this area someplace around here. So this is why many papers are written on a topic. So the ASI, the original authors wrote it, called it a 1-factor measure. Somebody else came out with a 3-factor version, or a factor analysis that said it's 3 factors. Somebody else said 2 factors. Another person said 4 factors. They looked at it in different populations, clinical versus regular. They came out with a hierarchical factor structure, which I'll mention in a few minutes. But there were a lot of papers written on the ASI just on the factor structure, and people arguing back and forth how many factors to take out of this measure. So as we're doing this analysis, you might come up with a different number of factors than other people do, and that's acceptable. I'm going to go through a third way to look at it, is how well it interprets. So we can use the eigenvalue. So take anything with an eigenvalue over 1. We can look at the scree plot, and then we can look at how it looks when you put it together. If we did the WAIS, we can look at verbal test versus performance test, and that's one way they used to look at the WAIS factor structure. So verbal tests are things like vocabulary, comprehension, similarities. Performance tests were things like coding, block design, and things that you perform with your hands. And that was a 2-factor structure, nice simple factor structure, the WAIS. it didn't really conform to a lot of like diagnoses or just a structure of intelligence, but it was a very simple way to explain the WAIS. So we're going to look at how easy it is to explain the measure as well. So let's look at once we do our rotation, we interpret, we start interpreting things. So one thing we'll want to have is what's called simple structure. I think it was Raymond Cattell talked about simple structure, and for each factor, we want items to load highly on it, and we want items that don't load on it to be as small as possible. And I'm going to show you what I'm talking about, because I don't think this makes much sense without an example. So we want high loadings when it loads on the factor and low loadings when it doesn't load on the factor. We also don't want items to load on multiple factors. And what's interesting, and I can give you some WAIS data if you want to look at that, arithmetic is one of the worst variables because it loads on more than one factor. And the Wechsler people really kind of hide this, and they don't actually show you the loadings on the other factors, but arithmetic loads on multiple factors. And you can kind of think like it's a working memory test. There's a bit of performance. It's a lot of things with arithmetic. All right, and some of the other things we'll look at is loadings of 40.4 or higher means that it loads on that factor. And then we'll name the variables. I'm going to talk about these steps, but let me actually do it conceptually. Again, here is the factor structure of the WAIS, and you can see this first factor. Usually they don't go above 1. Once in a while you get these weird numbers. So vocabulary loads really highly on this factor 1. So these are factors up here. Comprehension loads pretty highly. Information loads highly. Similarities loads highly. And arithmetic loads highly on this factor. So we want to take anything that loads 0.4 or above. And we can see here none of these other items load on this. This is not just a WAIS factor structure. They also have some other measures here, as you can see. The second factor, matrix reasoning, picture completion, picture arrangement, and block design, and the behavioral assessment of executive functioning. And then the third factor are these two, and then you can kind of see here the fourth factor is down here. So this is a nice simple structure on this. We don't have everything. When it loads on a factor, it loads above 0.4. And then when it doesn't load on the factor, it's a really small number. So some of the items that, like this one here, block design, kind of gets close to loading on factor 3, 0.21. Arithmetic has a high loading on this. That's really not that high though, but sometimes we'll get items that load on more than one factor, and that's when it gets a little bit more difficult to interpret. So this factor structure right here, I think is a nice clean structure, very easy to interpret. So this is something that we want to find. Here's the example from the ASI. I took 3 factors, and maybe you can help me name these. So I put them in yellow when it's above 0.4. And I'll kind of point out some abnormalities. This is real data, so there are abnormalities. So this one, 0.907 is really high. 0.795 is really high. I'll kind of take those two. So factor 1 is made up of, it scares me when my heart beats rapidly. It scares me when I feel faint. Scares me when I feel shaky, and scares me when I feel nauseous and shortness of breath. Those are the ones that are loading the highest. So I would call this factor physical symptoms of anxiety. So being afraid of physical sensations of anxiety. The second factor is I can't keep my mind on a task. I worry I might be going crazy. I worry that I might be going mentally ill. It scares me when I can't keep my mind on a task. This is what's been called mental incapacitation, the idea of that if I get anxious, I'll go crazy. This is maybe the cognitive discontrol, losing my mind factor as well. This third one scares me. It is important for me to not appear nervous and important for me to stay in control of my emotions. This one's been called the social component, so not showing your anxiety to others. So relatively simple structure, relatively easy to interpret. They came up with an ASIR, which had 36 items because they said that, you know, they didn't really have a lot for the social component. ASIR was kind of a disaster. Not a lot of people used it. It was just twice as many items, more than twice as many items. And then finally they came up with an ASI 3 with 18 items that add 2 more items to the social component. So, you know, if it's only 2 items on a factor, it's not that strong of a factor. So this is how they revised that measure. One thing I do want to show you, what do you do with this item here? Let me erase everything first. What do you do with this item here? It embarrasses me when my stomach growls. It loads on this first factor, so it's a bodily sensation. It makes sense to fit there, but it is almost loading on the second factor of that mind, that mental discontrol. So, you know, this item here is not that great, and it even loads on that social one. I mean, you can imagine if somebody's got a lot of anxiety about showing bodily sensations when their stomach growls loudly, that could be embarrassing to them. So this item is not the greatest item in regards to factor analysis. Maybe it's a great item that we want to get at, but with factor analysis, it doesn't load very clearly on any of those factors. Similarly, we've got this other item down here that other people notice when I feel shaky. You would think that this would load highly on the social, but it's not doing that and this is real data. It's maybe, you know, the way it's worded, it's not that it's not about caring if other people notice, it's just the other people notice I feel shaky. Maybe it's something along with that, but it loads on this, and somewhat loads on this. And also we've got, you know, a few items that this is above 0.4, so it's not perfectly what we called simple structure earlier. We don't have simple structure. We've got items that load on 2 factors, and we have some items that don't load very well on any of the factors. So this is probably what you're going to get in the real world with this type of factor analysis. And so we'll go through an example with this as we go. The rest of the slides that I have are just definitions. I don't think you need to go over the definitions. There's a lot of terms associated with factor analysis, so that's why I have a few extra slides just with definitions. The 2 chapters that I gave you are probably the simplest to understand the basics of factor analysis. I learned it with matrix algebra and learning the details of how to do it, and I felt like I never had the big picture. So I'm really trying to give you the big picture of it today without all of the terminology, without all of the matrix algebra behind it, that I think can confuse the situation rather than just clarify it. So the last few slides are just bonus if anybody's interested in those. So this is exploratory factor analysis. We went into detail with this. Next week we'll go into confirmatory, which is more when we have a theoretical idea of what's already occurred.